Imagine a world without the internet. No messages, no maps, no instant knowledge, no social network, no doom scrolling TikTok. Impossible, right? But what if I tell you that the world we live in today was created by the people who were preparing for the end of the world? This sound terrified America, not because it was loud, but because of what it represented. October 4th, 1957, the Soviet Union had just launched a beach ball-size satellite called Sputnik into orbit, and with it they launched a space age. But more importantly, they launched something else – pure existential fear. The story I'm about to tell you isn't about Silicon Valley entrepreneurs and the garage startups, it's about the psychologists and dreamers, the failed login attempts, and the happy accidents, military paranoia, and brilliant misfits who built something far greater than they ever imagined. This is a story of how Doomsday Machine connected the whole world, and the internet appeared. Let's go back to 1957. Dwight Eisenhower is the president, the Cold War is at its peak, and the Americans are looking up at the night sky with a mixture of wonder and terror, because up there, every 96 minutes a Soviet satellite is passing overhead, beeping its mechanical message: "We can reach you." The American public was stunned. How had Soviets beaten them to space? But the real fear wasn't about space exploration, it was about what this represented. If the Soviet could put a satellite in orbit, they could deliver a nuclear warhead to any city in America. The response was swift and dramatic. In February 1958, just 4 months after Sputnik, the US government created the Advanced Research Project Agency, ARPA. Their mission was simple: make sure America never gets caught off guard again by technological surprise. But here's where our story takes its first unexpected turn. In 1962, ARPA hired a man who wasn't thinking about war at all. His name was GCR Licklinder, Lick to his friends, and he was about to plan an idea that would accidentally change everything. Now Lick wasn't your typical military contractor, he was a psychologist, a philosopher really. While everyone else was building bigger bombs, faster jets, Lick was thinking about something much stranger. What if humans and computer could work together as partners? Picture the computers of 1962. These were room-sized monsters that spoke only in punch cards and printouts. You fed them a deck of cards, waited hours or days for results, and hope you hadn't made mistakes, because if you had, you start over. It was like sending a letter to someone in the next room and waiting a week for a reply. But Lick saw something different. He envisioned what he called man-computer symbiosis, a future where people could have a real-time conversation with the machines. More radically, he imagined connecting all this conversation together into something he playfully called the intergalactic network. In April 1963, Lick sent a memo to his colleagues. At the top, he addressed it to members and affiliates of the Intergalactic Computer Network. He was half joking about the name, but completely serious about the idea. He described a world where you could sit at any computer terminal and access programs, data and people everywhere in the world. Remember, this was 1963. Most people had never seen a computer, let alone imagine connecting them together across the globe. But Lick had something more than vision. He had budget. As the head of ARPA's Information Processing Techniques Office, he began funding the smartest computer scientists at the best universities – MIT, Stanford, UCLA, Carnegie Mellon. He didn't tell them to build the weapons, he told them to build the future. And then something magical happened. The brilliant minds scattered across the country started talking to each other, not just on the phone, but about shared ideas. They began to see Lick's vision. What if they could connect their computers directly? What if they could share resources, programs, data? What if they could create something larger than sum of its parts? By 1965, Lick had moved on other projects, but he had left behind something powerful, a community of believers and, more importantly, the funding to make their dreams real. The ghost in the machine wasn't artificial intelligence, it was the human connection. October 29th, 1969, UCLA, room 3420 in Boulter Hall. It is 10:30 at night and 21-year-old student programmer named Charlie Klein is about to make history. He doesn't know it yet. Klein is sitting at the computer terminal connected to a refrigerator-sized box called the Interface Message Processor, an IMP. Think of it as the world's first router, though they didn't call it that yet. This IMP is connected by the telephone line to another IMP 350 miles north at Stanford Research Institute. The plan is simple: log into Stanford computer from UCLA, type login and hit enter. It should work, should be in the operative phase. Klein has a phone headset on, connected to his counterpart at Stanford, Bill Duval. They are using the telephone network to coordinate this first test of packet switching, the technology that would eventually destroy the telephone network. The irony is perfect. "Are you ready?" Klein asks over the phone. "Ready," Duval replies from the Stanford. Klein types the letter L. "Did you get the L?" "Got the L." He types O. "Did you get the O?" "Got the O." He types G. The system crashes. The first message ever sent over what would become the internet was LO, as in hello and behold. It was perfect accidental poetry. But let's step back. How did we get to this moment? The story begins with the brilliant minds League had gathered. At MIT, there was Leonard Kleinrock, a young mathematician who had figured out something remarkable. In his 1962 doctoral thesis, he had described a new way of sending information across network. Instead of maintaining permanent connection between computers, like telephone calls, you could break messages into small packets, address each packet independently and let them find their own way through the network. Think of it like this: instead of reserving an entire highway for one conversation, you could chop up thousands of conversations into digital postcards, let them all share the same roads and reassemble them at their destination. It was radically more efficient. Meanwhile, at Stanford Research Institute there was Douglas Engelbart. Now Engelbart was a true visionary, some would say a prophet. In 1968 he had given what would later be called the mother of all demos. For 90 minutes, live on stage in San Francisco, he demonstrated a computer system that included Windows, hypertext, real-time text editing, video conferencing, collaborative editing, and something new he called a mouse. The audience of 1,000 computer professionals gave him a standing ovation. They had just seen the future. But all of these pieces need to be connected. That's where the interface message processor came in. The IMP, these ruggedized Honeywell mini-computers, were built by a Cambridge company called Bolt, Bernard and Newman, BBN. BBN was a fascinating company started by two MIT professors as an acoustical consulting firm. They had helped design the UN General Assembly Hall. It had evolved into a hybrid of academia and industry. They attracted brilliant minds who wanted to work on impossible problems. The IMP was deceptively simple. A special-purpose computer that sat between each university's main computer and network. It spoke the local computer's language on the one side and the common network language on the other. It was like having a universal translator at every node. Back to the night in October 1969. After the crash, Klein and Duval spent an hour troubleshooting. Then they tried again. This time it worked. Login appeared on the Stanford screen, sent from UCLA. The first successful host-to-host message on ARPANET was complete. But here's what's remarkable. Within months, they had connected 4 computers: UCLA, Stanford, UC Santa Barbara, and the University of Utah. By 1971 there were 15 nodes, by 1972 37 nodes. The network was growing, but something unexpected was happening. The researchers had built ARPANET to share computer resources, expensive processors, storage and programs. That's what the funding was for. But the scientists did something else entirely. They started talking to each other. In 1971, a BBN engineer named Ray Thompson was working on a simple program that let users leave messages for each other on the same computer. But then he had an idea. What if he could send a message between computers on the network? He chose @ to separate the username from the computer's name. The first network email was sent from one computer to another computer sitting right next to it in the same room, but routed through the ARPANET. The message was a meaningless test string, but the impact was anything but meaningless. Within 2 years, 75% of all ARPANET traffic was email. The military had founded a resource-sharing network and accidentally created the first social network. By the early 1970s, ARPANET was a success, but it was also a problem. Picture this: ARPANET was like an exclusive club. It connected universities and research centers using a specific technology and specific set of rules. But other networks were sprouting up everywhere. There was AlohaNet in Hawaii using radio waves to connect islands. There were satellite networks connecting different continents. There were private corporate networks using a different technology entirely. Each network spoke its own language. They couldn't talk to each other. It was like having dozens of telephone systems that could only call phones within their own system. This was the Tower of Babel problem of the digital age. Enter two the most important people you've probably never heard of, Vint Cerf and Bob Kahn. Cerf was a soft-spoken computer scientist who wore three-piece suits to work, unusual in the casual world of computing. Kahn was a brilliant engineer who had worked on ARPANET's design at BBN. In 1973, they began collaborating on what would become the most important piece of software ever written. The challenge was profound. How do you connect networks that use different technologies, different hardware, different rules? How do you create a network of networks? They came up with the elegant solution. Instead of trying to make all networks compatible, they created a universal language that could run on top of any network. They call it TCP/IP, Transmission Control Protocol, Internet Protocol. Here's how it works, using an analogy everyone can understand. Imagine you want to send a book to a friend in another country. You can't email the entire book as one package. It's too big and might get lost. Instead, you tear out each page, put it in its own envelope, write the destination address and page number on each envelope, and email them separately. Some envelopes might go by ship, others by plane, others by truck. Some might take detours or get delayed, but each envelopes know where it's going and what order it belongs in. When all the envelopes arrive at your friend's house, they reassemble the package in the correct order and voila, your friend has the complete book. That's TCP/IP. The book is your data, an email, a file, a photo. TCP tears it into packets and reassembles it at the destination. IP makes sure each packet knows how to get there, routing through whatever networks are available. It was brilliant because it was simple. Cerf and Kahn like to say TCP/IP could run over 2 tin cans and string. Any network could join the internet, the network of networks, as long as it spoke TCP/IP. The first test of internet working happened in 1975, connecting ARPANET to a satellite network and the radio network. A van driving around California sent a message through its radio network, which forwarded it through ARPANET, which sent it via satellite to a computer in London. The message traveled 94,000 miles to go a few thousand miles, but it worked. By 1983, TCP/IP became the mandatory protocol for ARPANET. The Internet Capital One was born. But throughout all this technical innovation, the human element remained central. Email continued to be the killer app that no one had planned for. By the mid-1970s, ARPANET wasn't just connecting computers. It was connecting communities, scientists collaborating across the continents, researchers sharing not just data, but ideas, gossip and friendship. The network had become a place where you could live part of your life. Early users developed their own culture, their own etiquette, their own slang. They created mailing lists, the first online forums. They built systems for sharing files, playing games, and even shopping. The military's survivable communication network had become humanity's first digital civilization. But this digital world was still exclusive. By the early 1980s, ARPANET connected hundreds of computers at dozens of universities and research centers. Maybe a few thousand people had access. The vast majority of the world didn't even know it existed. That was about to change, but not how anyone expected. 1983 was a turning point in more ways than one. First, ARPANET itself was split in two. The military, concerned about security as the network grew, created the MILNET for military communication and left ARPANET for research. The internet now consisted of multiple interconnected networks, exactly what Kerr and Hahn had envisioned. Second, the National Science Foundation began building NSF-NET, a new backbone network connecting universities across America. This wasn't just a computer science researchers anymore. Any academical discipline could use it. Biology, chemistry, physics, literature, suddenly scholars across every field had access to instant communication and information sharing. The growth was explosive. In 1983, there were 562 computers on the internet. By 1987, there were 28,000. By 1989, 160,000. The network was doubling in size every year, but it was still an academical network. Commercial use was forbidden. No businesses, no advertising, no selling. The internet was a publicly funded research tool. That changed in the early 1990s, when the NSF began allowing commercial traffic. By 1995, the NSF-NET backbone was shut down, and the internet was fully privatized. Commercial providers took over and the gold rush was on. But even by 1990s, the internet was still a specialist tool. You need to know Unix command, understand file transfer protocols, navigate complex directory structures. It was powerful, but it certainly wasn't user-friendly. That's where our final character enters the story. Switzerland, 1989, at CERN, the European Particle Physics Laboratory. A British computer scientist named Tim Berners-Lee was frustrated. CERN was like a microcosm of global research community. Scientists from dozens of countries worked on the experiments involving thousands of people. They used different computers, different software, different ways of organizing information. Finding anything was a nightmare. Berners-Lee had an idea. What if there was a universal way to link documents together, not just on one computer, but across all computers on the internet? What if you could click on word or phrase and instantly jump to related information, regardless of where it was stored, on what computer it was on? He called it the World Wide Web. Now, this is important to understand. Berners-Lee didn't invent the internet. The internet was already there, a robust network connecting millions of computers worldwide. What Berners-Lee invented was a user-friendly way to navigate it. Think of it this way. The internet was like having roads connecting every city in the world, but no street signs, no maps, no addresses. The web was like putting up street signs, creating maps, and establishing a postal system all at once. Berners-Lee created three fundamental technologies. HTML, a simple language for creating documents with links to other documents. HTTP, a protocol for requesting and receiving these documents over the internet. URLs, universal addresses so any documents anywhere could be found and linked. In 1990s he built the first web browser, which he called World Wide Web, and the first web server. By 1999 he had convinced CERN to make the web software freely available to everyone. The impact was immediate and revolutionary. The first web browser for regular people, called Mosaic, was released in 1993. Suddenly anyone could point and click their way around the internet. No commands to memorize, no complex procedures to follow. By 1994 there were 3,000 websites, by 1996 100,000, by 1998 millions. The web made the internet accessible to everyone. And here is where our story comes full circle. Remember Leake's vision of the intergalactic network? A world where anyone could access information and programs from anywhere, where computers would augment human intelligence and enable collaboration across any distance. By the late 1990s, his impossible dream became the everyday reality. The military survivable communication network had become the foundation for global commerce, entertainment, education, and the social connection. The tool designed to function after nuclear war had become the primary way humans shared knowledge, culture, and love. Today, more than 5 billion people use the internet. They send 300 billions of email per day and share billions of photos and conduct trillions of dollars in e-commerce. And we got access to the humankind knowledge just few taps away on the screen that we carry in a pocket. All because psychologists had the dream, a few engineers want to share computer resources, and students' failed attempt to log in crashed after 2 letters. So next time you send a message, watch video, or just lost in the sea of information, remember where it's all started. It's a reminder that the most world-changing innovations are messy and completely accidental. If you like this video, please share it with your friends, hit the like button and subscribe. And thank you for watching, see you in the next one. Bye!